Hello friends, welcome to my YouTube channel. This is Namakanda the Scientist. So please, if you've not yet subscribed, consider doing so that you're always updated whenever there's a new upload. So with me I have this question that you can see here, which says that calculate the velocity of the electron with the de Broglie wavelength of 312 nanometers. Okay, so this is what we have. Now, de Broglie wavelength is a very important concept in quantum physics. So this is why you simply have that the same de Broglie wavelength is simply associated with an object that is in relation to its momentum and mass. Now here, since we're taught to find the velocity of an electron given the Broglie's wavelength of that magnitude, which is 312 nanometers. So what we're going to simply do here now is we're simply going to use the equation. We're simply going to use de Broglie wavelength equation. So what's de Broglie's equation? So this is given as the wavelength to be equal to h, which is the Planck's constant. So we have the wavelength to be equal to h over the momentum of the electron, which can be simplified further by saying lambda is equal to h, which is the Planck's constant, over mv, which is the formula for momentum. Now the value for h, which is the Planck's constant, is given, lambda is given, the mass of an electron is also some figure that is known. So what we are supposed to find here or solve for is the velocity of this electron. Now what we're going to do is we're going to cross multiply to make it subject to formula, so we get like that equal to h there. Then we divide both sides by lambda m, even on the right by lambda m. So this will give us our velocity to be equal to Planck's constant over the wavelength times the mass of the electron. So that's how we're going to find the velocity. Now the Planck's constant is given as 6.626 times 10 to the power negative 34 joules seconds as the units. So this might be given in an exam. Then the mass of an electron is given as 9.109 times 10 to the power negative 31 kgs. Okay, then also the wavelength is given there in the question. Sorry, wavelength there, not h. So lambda there is given as 312 nanometers. So we're going to change it to meters. So we'll simply multiply by 10 to the power negative 9. So that's what we're going to have in meters. Now since we have all the values that are needed to solve our question, let us now start with solving for velocity. So we say we put the one for Planck's constant there, where there's h, times 10 to the power negative 34. Then we divide with, so when you multiply the mass in lambda, there you simply get 2.84 times 10 to the power negative 37 times 10 to the power negative 37 upon multiplying the mass in the wavelength. Then when everything is divided, when we divide there, we're simply going to get the value for the velocity. Our velocity in this case will simply be equal to 2,333.1 meters per second.